Welcome to Data Unscripted, the podcast where we discuss everything data related and in short and to the point episodes. I'm Ori, and with me is my co-host Duddy. How's it going, Duddy?
Doing good, doing good. How about yourself?
Not too bad, thanks. Today, Duddy, we're going to talk about a big subject, the analytics data development tech stack and the components that make up this stack. It's a big subject, so to get started, can you just start by giving us a high-level overview of the end-to-end analytics data development process?
Yeah, sure thing. Okay, so let's start with the 10,000 feet view of analytics data development. Simply, you take data from different sources, centralize it in one place, transform and manipulate it, and then analyze that data using various tools.
That sounds straightforward. Why do I have a feeling it gets much more complex later on?
Because you're absolutely right. Let's drill down. So we talked about the first step, taking everything and putting it in one single place. This is called data ingestion. You pull all your data from various sources. It could be from databases to APIs to SaaS platforms like Salesforce. So you basically take the data in its rawest format and store it in one place. Organizations usually use cloud data warehouse or databases to store that data. Once that data is in your data warehouse, you transform the data, meaning you cleanse it, you remove duplicates, aggregates, and so on and so forth, so that you now have tables in your data warehouse that analysts or other stakeholders like data scientists can use to do analysis, run AI jobs, produce dashboards, reports, and so forth, and so on.
Got it. This is definitely a little bit more complex. To unpack it, why don't we start with data ingestion and talk about the common tools we see in the market?
Okay, so data ingestion, as I said, is the first step, usually handled by data engineers or sometimes by analytics engineers. Sometimes they could write their own tools to connect to APIs or their own operational database and pull data in. But most companies use either open source tools like Airbyte or services such as Fivetran to do that ingestion.
Got it. Okay. So we have the data now. We're pulling it in. Let's talk about the data warehouse part.
Okay, cool. So all data resides in a single place. This is most often a data warehouse like Snowflake, BigQuery, Redshift, etc. The architecture of that warehouse varies by how structured you want the data to be. Data warehouse usually have a very clear schema, meaning clear tables and column definitions. But on the other side of the spectrum, you have the data lake, where you basically have no schema or structure. There's a trade-off here, right? So in the data lake architecture, it's usually stored in files, mostly Parquet formats. But lately, there's this notion of data lakehouse. This architecture combines the control and structure of a data warehouse with the flexibility and low cost of data lakes.
Got it. So we have the data, we brought it in, we put it in one place, data warehouse, data lake. What about the data transformation itself?
Okay. This is where things get very complex and dynamic. Okay, so you got the data, it's raw, and you need to manipulate it to be able to consume it on the other end. So data transformation includes multiple different steps, from data modeling to documentation to data testing, validation, observability, continuous deployment, and even things like lineage and other stuff.
Okay, let's take it one step at a time then. Let's start with data modeling.
Okay. So data modeling is most commonly done in SQL or Python. It's basically coding, right? It's done by analytics engineers, but also it could be data analysts, or it could even be a product manager who's proficient with SQL, okay?
Anyone who knows a little bit of coding, basically.
Exactly. So some companies use pure SQL and Git to manage the source control and the version and run that code. And others use an open source tool called dbt, which is data build tool. But there are many other ways to do data modeling.
Okay. What about data validation, documentation, that stuff?
Right. Okay. So data validation is testing the data models that you just created. Sometimes this is done simply in code. It could be in a configuration file like YAML files or JSON files. But some companies could use tools like a Datafold or Great Expectations that do the data validation for you. You mentioned documentation. This is a whole different story. Okay, so good documentation is super important. Large companies invest in products called data catalogs that are centralizing the documentation in a single place of all the data assets. These are typically complex, expensive solutions like Atlin or Elation, but there are also open source solutions like Open Metadata for data catalogs.
Got it. What about the analysis of data? If we are here now, it means we have gotten all the data into a data warehouse. We've done the transformation. We've tested the data. We documented the data. But of course, the end goal is to actually do something with the data, which is analysis.
Yeah, so that's a great question. So once the data is correctly structured in your data warehouse and tables, data analysts and other data consumers like data scientists could use tools like Tableau, Looker, Power BI to do dashboarding, reports, or ad hoc analysis on top of that data. But the important thing to note here is you need to decouple the presentation logic. This is where you actually visualize the report, and the business logic, where you cleanse the data, model it, and basically create a single source of truth of all your data assets.
It's a great point. So we've gone through a lot of steps, but I'm missing one thing. How do you manage this complex process end to end?
Yeah, okay, good question. So you need to have like an orchestrator that basically schedules and runs everything together. These orchestrators are tools that allow you to define a workflow that has multiple steps. For example, start with ingesting the data, transforming the data, refreshing reports and dashboards, maybe notify relevant stakeholders that new data flowed in, that kind of stuff. The most popular tool in that area is Airflow, but there are the tools like Dagster, or you could implement that internally by yourself.
Okay. Sounds like a complex stack to assemble from start to finish, I have to say. I've been hearing a lot lately about something called the unified data platform approach. Obviously, you have the best of breed versus best of suite approach.
Yes.
Can you talk a little bit about the differences?
Yes. Okay. This is a fascinating dynamics in the data industry. So traditionally, companies would pick the best tool for each step in the data transformation that I just mentioned, where most of the work takes place. It could be DBT for data modeling, Atlin for data catalog, Monte Carlo for data observability. Right. So this best of breed approach, that's what it's called, gives you top tier capabilities in each of these areas. But the trade-off here is that you're responsible to integrate everything and maintain all those different tools, which could be a lot of hassle.
It's also very expensive probably because you're talking about separate tools, you need separate licenses, separate seats,
exactly.
Administration of each and every one of these tools separately.
Yeah, that's absolutely right. On the other hand, the unified platform approach offers everything in one integrated solution. You might sacrifice some specialized features, but you gain massive efficiency in setup, maintenance, collaboration, cost, and most importantly, ease of use. Montari is one example of such platforms, but there are other players in this field.
Got it. I gotta say that's a lot to digest for one episode. It's also all the time we have for today. So thanks, Dadi, and we'll see you all next time.
Yeah, sure thing. Talk to you later.
Bye-bye.
Bye-bye.